Fresh water is fast becoming a limiting resource for South Africa, and the need for more desalination plants is being mooted. South Africa already has a handful of plants in the coastal areas, with 6 more being spoken about. In studio now to talk about the issue is Teboho Mofokeng, Technical Executive at GIBB Engineering. Teboho, welcome. Such an interesting topic. A simple question to start though, do desalination plants always have to be on coastal areas?
Yes, they do. By default, the desalination process is about getting seawater, removing the salt content of the seawater and treating it to a potable drinking standard. So we couldn't build a desalination plant in Gauteng, for example. But
there are some instances where they can do the same thing for brackish water, which is inland.
Okay, fair enough. So with desalination, it depends on the type of contamination of the water.
Yeah.
So
okay.
it's essentially a water with a salt content. So it can be seawater, it can be brackish water, it can be acid mine water, for example, which has various mineral content because of leachate in underground from the mining activities.
Would that work for Gauteng?
Yes.
Is it being mooted? Is it being spoken about? Is there a way to deal with the whole issue?
I think there's a tender out at the moment which is busy being adjudicated to treat the West Rand mines and find a
good. Well,
a
that would be one solution for this big problem that we have in Gauteng.
Yes.
So there are 6 plants which are being spoken about, 2 in the public sector and 4 in the private sector. The 2 in the public sector, is that the whole deal with Iran?
The 2 in the
public sector.
The Kubik one.
Yeah.
Look, they're still in feasibility stage. There's still a lot of planning that needs to happen. Yes, it's attached to the water requirements for the nuclear process, the 2 in the public sector. The 2 in the private sector is looking at different ways to partner with government to assist with the drought situation in the Western Cape. But right now, the Western Cape is not ready for implementation yet. There's still a lot of feeling to see if it is feasible for them.
Yeah, and there's a whole lot of feasibility work that needs to be done. Let's go through some of the issues. Desalination is very expensive. Total cost is between 11 and 16 Rand per cubic meter.
The cost associated with it is that, okay, so when we desalinate, we basically, in essence, using reverse osmosis. For example, osmosis, plants normally get their water intake through osmosis. Water flows from a place where there's a high salt content, so it will move into the roots. So when we do reverse osmosis, we're almost forcing the water out of the roots into its surroundings, if you could picture that, and that requires a lot of power. So in order to remove the salts, we have to apply a lot of pressure to do that. We also have to have long extraction lines to get it out of the sea, and there's pumping costs required to bring it to the treatment plant. Even though there have been improvements in technology, it still doesn't drastically reduce the energy requirement.
And it's very expensive, and of course energy being a big part of that, when the whole world is trying to get into a carbon neutral situation.
Yes.
But one thing I noticed, I thought was quite markedly absent from the presentation from GIBB Engineering, is that there was nothing to do with environment. Now, there's lots of cases about how bad this is for the environment in many different ways, one of them being that fish and sea life is drawn into those extraction pipes.
Absolutely. The environment is probably normally the biggest stumbling block. For example, we will extract the water and the salt content of the return water is twice that of what we extracted. There's still lots of research to see what impact that will have on the sea ecology over time, because the sea ecology is not meant to be operating at that salt content. Totally agree with you regarding the finer microscopic ecology that we don't see, that we would extract. Now, there are measures to put filters in where you would find out the microscopic size and filter them and return them back to the sea. But from a sustainability point of view, we can't all go build desalination plants all over the world, because that would drastically have a huge impact
But
on our
the modern
oceans.
way of doing business is to think of 6 capitals and not only one capital being financial. And it's quite surprising to me that engineering companies do not, they just look at one, financial and maybe manufacturing, but ignore all the other capitals which are needed for a longer term sustainability process.
Look, I think we can't afford to only be one-track minded and only look at the capital side of it. We also need to look at the operation and maintenance side of things. We need to look at the environmental capital costs that it will have long-term that we might not even be able to reverse. Because some of those we'd need to find a location for the plant on pristine beach land, and you are going to disturb it. You can't help that. And given the size of, for example, Cape Town, you're not going to build a small plant. You're going to build a big plant for economies of scale so that you can actually provide for the whole of Cape Town. So your impact is going to be that much more. I would really like to think that the engineering mind has changed, and we are looking for sustainable ways to find solutions instead of just capital-intensive solutions.
Given all these problems, Teboho, then why don't we as South Africans go for cheaper and more efficient ways of finding water? Now, for one, it's fixing up the water pipes in South Africa, which are so badly decomposed, and I think about 1/3 of the water or something drastic is lost through them.
Look, I think if you look at the planning requirements that the Department of Water Affairs is imposing on municipalities. For example, you can't upgrade a water facility unless if you can show that you are first trying to conserve the water. So you must show them that here's my water demand management plan. This is how I manage leaks. This is how I manage my customers if they detect a leak. This is my turnaround time. I think our plans are good. We normally struggle with execution. And I do agree that to solve our water issue, we probably also need to step back a little bit and fix our water culture.
Yeah, absolutely.
Because our water culture should be one of conservation.
Yeah.
For example, Israel has done that very well. Their nursery rhymes is, rain, rain, don't go away. What's our nursery rhyme for rain? Rain, rain, go away, come back another day.
We have to end it on that wonderful point. Thank you. It's lovely to have you in studio, Teboho.
Thank you very much.
Teboho Mofokeng, Technical Executive at GIBB Engineering.